Buoyancy. Problem solving. Problem number 1. A block of wood 0.2 meters thick is floating in seawater. The specific gravity of wood is 0.65 while that of seawater is 1.03. Find the minimum area of the block which will support a man weighing 80 kilograms. For situational problems such as this, you first have to visualize what the problem is actually telling you. So for this problem, there is a certain man standing on top of a certain wood block which is floating in seawater. So the problem says it supports the man, which means the man and the wood block is not sinking. So upon the analysis of that certain illustration, you have to construct the three-body diagram since there are forces affecting this scenario to happen. So the first force that affects it will be the weight of the man, also the weight of the wood, and the buoyant force, which is the effect of the seawater on that certain wood block. The problem requires for you to find the minimum area which will support a man weighing 80 kilograms. As for the solution, upon the analysis of the free body diagram, this will be the working equation for this problem. The summation of the vertical forces will be equal to 0. This point was actually gathered when the problem says that the certain block of wood and the man does float, which means the buoyant force will be equal to the weight of the wood and the weight of the man. So considering the summation of vertical forces, the buoyant force is subtracted from the weight of the wood and the weight of the man. You have to remember that these three forces were not directly given in the problem. So you have to use your algebraic manipulation to be able to come up with the proper equations for each force. So the buoyant force due to seawater will be given as the formula for the buoyant force, and that will be specific weight of seawater multiplied by the volume of the submerged object. Note, since the specific weight of seawater were not directly given in the problem, expand the equation as the specific gravity of seawater multiplied by the specific weight of the reference fluid. And also, since the volume of the submerged were not directly given in the problem again, expand the equation as the area of the submerged object multiplied by the draft. The weight of the wood will be given as the specific weight of wood multiplied by the volume of the wood. Again, with the same scenario as the first one, it will be expanded to the specific gravity of wood multiplied by the specific weight of the reference fluid. And also, the volume of the wood is not again directly given. That means the area of the wood multiplied by the draft will be the volume of the wood. And the weight of the man will be given as the mass of the man multiplied by gravitational acceleration. So to avoid confusion, you may separate the computation for all the existing forces. So for the buoyant force due to seawater, it will be given by this equation. You have to remember that the area of the submerged is what the problem requires, so it will remain as a variable concept. So upon the substitution, 1.03 as the specific gravity of seawater multiplied by 9.81 kN per cubic meter, the specific weight of the reference fluid, and the 0.2 meters as the draft, thus giving you a variable value of the buoyant force as 2020.86 area of the submerged Newton per cubic meter. Since the weight of the wood is the same as the buoyant force, you have to multiply the specific gravity of wood by the specific weight of the reference fluid multiplied by the draft. The area of the wood is also what the problem requires, so So it will give you the weight of the wood as 1,275.3 area of the wood Newton per square meter. The weight of the man will be given as 80 kilograms multiplied by 9.81 meter per second squared, thus giving you 784.8 newtons. It may seem confusing since area of the submerged and area of the wood has different subscript, but you have to remember that the problem states that the wood is fully submerged in the water, which means the area of the submerged object and the area of the wood is the same. And that is also what the problem requires, the minimum area which will support the man weighing 80 kilograms. So upon the substitution of all the computed forces affecting in that certain problem, it will give you the area of 1.0526 squared meter.